This video is prepared by Avya Classes. Please subscribe the channel, raise your doubt and watch the video for sure success in JEE, AIMS and NEET.
Discuss unit and dimension of force. So what is dimension of force? So as we know that force is equal to mass into acceleration. So to get the dimension of force, we just multiply the dimension of mass and acceleration. So dimension of mass is m, dimension of acceleration is lt minus 2. So the dimension of force is mlt minus 2. Now we'll see the units of force. So basically the units of force are divided into two ways. First is absolute unit, second is gravitational unit. So what is absolute unit? Absolute units are Newton in terms of SI, while in CGS it is called as dyne. So what is Newton and what is dyne? And for gravitational unit, it's in MKS it's called as kilogram force, and in CGS it's called as gram force. So first we will learn absolute unit. So absolute unit in SI we call at Newton. So what is Newton? So as we know that F is equal to ma. So from this formula the term Newton is divided. Like if I take m is equal to 1, a is equal to 1, then F is equal to 1 Newton. So basically m is equal to 1 kg, a is equal to 1 meter per second square. So if a mass of 1 kg is moved with an acceleration of 1 meter per second square, then the force needed for this is called as 1 Newton, and is written here 1 Newton is that force which produces an acceleration of 1 meter per second square in a body of mass 1 kilogram. So 1 Newton is equal to 1 kilogram per second square. Now we will see the value of dyne. So what is dyne? So instead of SI terms, if I use mass and acceleration in terms of CG stuff, we get the value of dyne. That is, 1 dyne is the force that produces an acceleration of 1 centimeter per square in a body of mass 1 gram. That is, as F is equal to ma. So now instead of 1 kilogram, we consider the mass of body as 1 gram and acceleration of body as 1 centimeter per second square. So 1 dyne is that force which produces an acceleration of 1 centimeter per square in a body of mass 1 gram. So 1 dyne is equal to 1 gram centimeter per second square. So I think absolute unit is clear to you. Now we will define the relationship between Newton and dyne. So 1 Newton is 10 to the power 5 dyne. So you should keep this in your mind, that 1 Newton is 10 to the power 5 dyne. Sometimes it may be asked in the examination. So how we will get this value? So basically 1 Newton is equal to 1 kg into 1 meter per second square. So now we will convert this this kg into gram. So 1000 gram into, and this meter per second square to centimeter per second square. So it's 100 centimeter per second square. So from there we get 10 to the power 5 gram centimeter per second square, and as we know that the gram centimeter per second square is called as dyne. So we write it 10 to the power 5 dyne. So 1 Newton is equal to 10 to the power 5 dyne. So I think this is clear to you, that how we get the relationship between these two, and what are the absolute units of force. Now we will consider the gravitational unit of force. So gravitational unit of force, So basically it is the force that first we will define kilogram force. So what is kilogram force? It is that force which produces an acceleration of 9.8 meter per second square in a body of mass 1 kilogram. As we know that the acceleration produced by a gravity or the acceleration due to gravitational force is denoted by g, and it is the value of g is equal to 9.8 meter per second square. So this is basically gravitational unit. So it is related to the acceleration due to gravity. So if I consider a mass of 1 kilogram, then it is the force that produces an acceleration equal to g in a body of mass 1 kilogram. That's why it's called as the gravitational unit. So 1 kilogram force is equal to 9.8 newton. So how we will calculate it? That F is equal to ma, and m is 1 kg. Acceleration is equal to 9.8 meter per second square. So from there we get 9.8 kg meter per second square is equal to 9.8 newton. So if you see that 1 kilogram force is equal to 9.81 newton. Now we will see gram force. So what is this gram force? It is the force that produces an acceleration of 980 centimeter per second square in a body of mass 1 gram. So here instead of mass is equal to 1 kilogram, we consider mass is equal to 1 gram and acceleration is equal to 980 centimeter per second square. As we know that acceleration due to gravity is equal to 9.81 or 9.80 meter per second square. So basically in terms of centimeter per second square, it is 980 centimeter per second square. So for a mass equal to 1 gram, if the acceleration produced is equal to 980 centimeter per second square, then this force is called as gram force. So basically 1 gram force is equal to 1 gram mass produced with 980 centimeter per second square. So if you consider it must be equal to 1 gram force, or we write here that 1 gram force is equal to 980 gram centimeter per second square. So this is equal to dyne. So basically 1 gram force is equal to 980 dyne. So you should keep this in your mind that 1 kilogram force is 9.81 newton and 1 gram force is 980 dyne. And what is the relation between gravitational unit of force? That is 1 kilogram force is equal to 10 to the power q gram force. Simply you convert kilogram into gram and you will get this relation. So 1 kilogram force is 10 to the power 3 gram force. So these some relations are important to you. First is the 1 newton is 10 to the power 5 dyne, 1 kilogram force is 9.81 newton and 1 gram force is 980 dyne, 1 kilogram force is 10 to the power q gram force. Now we will see more concepts related to force. First thing is that no force is required to move a body uniformly along a straight line. It's quite clear that here the word uniformly comes in picture. Here the words uniformly. So what is meant by uniformly? Uniformly means velocity is equal to constant. Means there is no any acceleration. So as acceleration is equal to 0, so force is equal to 0, or the velocity is not changing, so force is equal to constant. And as this body is moving along a straight line, so only magnitude may change, and here magnitude is not changing as velocity is constant, so force is not required. However, if a body moves uniformly or uniform velocity along a circular path, like if a body moves with uniform angular velocity omega along a circular path, then force is needed because here the direction is changing. At this point the direction in this way, at this point this is direction tangential to this way, that is direction at any point is tangential to the path. So as you see that the velocity vector is changing, and as velocity vector is changing, a force is needed. This force is called as centripetal force, which acts towards the center, and its value is equal to m omega square r is equal to mv square by r. If you have any doubt related to centripetal or any related to circular motion, you just refer my notes of circular motion.